Guys, what's going on? This is lesson 4.1. We're going to start talking about sampling and surveys and how to sample well, how to sample poorly. The first thing that we're going to talk about is what the difference is between a population and a sample. Um, a population is all of the things, like the entire group of individuals that you want information about. So if you're looking at the GACS high school student body as your population, that's every student that's between ninth grade and 12th grade. That's your entire population. And let's say we're trying to figure out the average height of the entire student body or the entire high school student body at GACS. That's the information that we want. The group of individuals is the population. That's the student body. Okay, and a sample is just a subset of individuals in the population for which we actually collect the data. So what that means is it's really hard for us to get um, all the information about everybody in our population. Think about it in terms of GACS student body. There's about 650 students in the high school. So that means that we'd have to go to every student in the high school, 650 students, and get their height just to get the average height. That will take a long time. So what we could do is we can take a sample of that population, take a smaller number of students, find their height, and that can give us a good estimate of what the average height is. So that's what a sample is. A census is us actually getting the information about that entire population. Again, really hard to do. If you think about the United States Census, they do one every 10 years and they send out a form and everybody has to fill it out, and they get a bunch of information from all of the people that are in the United States. It's not just how many people are in the United States. It's all this information. That's a census. That's a big thing, and so it takes a long time to do that. All right. So, convenience samples. Let's talk about what a convenience sample is first, and then we'll talk about the problem with a convenience sample. A convenience sample would be an example of that would be if I was outside of the mall and I wanted to figure out my information that I wanted was how much time teenagers usually spend in the mall, and every teenager that walks up to me, I'd asked how often they or how long they spend in the mall in a given week. That's a convenience sample. My entire population isn't really represented because what about the teenagers that don't even ever go to the mall? There's no way that I'm ever going to have them in my sample. So it's a convenience sample in that sense. Talk about the GACS student example when we're trying to find average height. A convenience sample would be like if I went to the, I don't know, outside a 12th grade English class and just got everybody's height that was walking into that class. That's a convenience sample. It's not going to be representative of my population. So the problem with that, is that it often produces unrepresentative data, unrepresentative of my population. I'm going to get a result, an estimate that isn't representative of my population, which isn't a good thing. Okay, and this tends to lead to a sample that is biased. Okay, a sample that is biased. A bias is when you use a method of obtaining a sample that will consistently overestimate or underestimate the value we want to know. Okay, so it's normally the values are too high or too low on a consistent basis. We want unbiased methods. Unbiased methods will give us kind of a symmetric distribution. Some values will be too high, some values will be too low, but they're going to be centered around the actual true value. That's our goal. Okay. Now, what is a voluntary response sample? The best explanation that I can give is like shows like America's Got Talent or The Voice. A voluntary response sample, the way that they pick the winner is people just call in. Anybody can call in. It's voluntary as to who responds. There is no limit to the number of people who respond. So a voluntary response sample is when somebody can choose to call in or not. So a sample that consists of people who choose themselves by responding to a general invitation. This is not a good method for obtaining a sample because it's going to lead to people who are very invested in whatever they're doing to be calling in or emailing or whatever or responding to the sample. Okay, so that's not necessarily a good thing. So let's take a look at a couple of examples, kind of go through what kind of sampling method this is and why this could be an issue. So the first example, it says a farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all oranges. What is wrong with this procedure? Well, this is a convenience sample. The juice company is just looking at the top oranges. They're not really doing anything more than that. It's just convenient for them to do that. So the problem with that, if I'm the farmer, I'm going to put all of my best oranges on the top so that the juice company will buy the oranges for me. Okay, so that's the issue with that. Number two says the ABC program Nightline once asked whether the UN should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded and 67% said no. So this is an example of a voluntary response sample. You could call if you wanted to. You didn't have to. There was a charge for calling, so that even adds another kind of barrier for calling. The problem with this is it's probably going to lead towards the people that are really, really passionate about this issue to respond. So it's going to overestimate the percentage of people that said no. So that's an issue. Okay. So that's how to sample badly. Those are two sampling methods that are not good. Let's talk about how to sample well. So one sampling method that is kind of the easiest thing for us to do is called a simple random sample, or an SRS. A simple random sample is a sample that is chosen in such a way that every group of n individuals in the population, has an equal chance to be selected as the sample. So let's say I had 18 students in my statistics class, and I wanted groups of 3 or samples of size 3. Every single group of size 3 has the same chance of being selected in an SRS. Okay. So how do I go about doing that? There are 2 ways that we can do that. And I apologize, I don't have the TI-84 Smart View on my calculator, so I can't show you on the calculator how to do that. For those that weren't in class, come see me and I'll kind of go over this process. But one way to do that is to create random integers. So I would assign every student an integer or a number from 1 to 18, and then I randomly select 3 numbers. Okay. We're going to talk about with and without replacement here in a second in that, but that's how I would do it. And there's a way on the calculator that we can randomly select 3 numbers. Okay. The other way that we can choose an SRS, which is the way that I would always describe on an AP exam or a question like this, how to generate a simple random sample, is put all the names in a hat, all 18 names in a hat, and pull out 3 names. And those are the 3 people that are in my sample. So if we're going in terms of like the GAC student body and the average height, how would I do an SRS? Well, I would assign each student in the high school a number from 1 to however many students there are. And then I would, let's say my sample is size 40. I would take 40 random numbers and I would figure out who those students are that correspond with those numbers, and those are the students that I need to find out what their height is. And then I would average up my heights and figure out what my estimation of my average heights is. Okay, so that's what a simple random sample is, chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. So what is the difference between sampling with replacement and sampling without replacement? So sampling with replacement is if I pull out somebody or an individual in my sample and I put that number back in. The reason that we would do something like that is if we were simulating some like chance process and we had assigned digits to yes or digits to no. In this case, I would be sampling with replacement. Okay, sampling with replacement is the sample values are independent. So it doesn't, knowing the value of the first person or thing doesn't affect the probability of the next thing. Okay. That's what independent means. Sampling without replacement is generally what we'll do when we're trying to create a sample from a group, from a big population, and we're trying to find something out about that population. These sample values are not independent, and so I would not be replacing the number or the piece of paper in the hat once I select that number. Okay. So I have this example. It's about mall hours. It says the management company of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. So I think I have 21 stores here. So what I would do, I would come in here and I would say, okay, Aeropostale is number 1, All American Burger is 2, Arby's is 3, 4, 5, and so on. And I would number them all the way down to 21. Okay. And then I would, in my random number generator, generate 3 random numbers from 21. And I would be doing this without replacement, okay, because I want 3 unique stores to determine their hours. Okay, again, I apologize I can't do this on my computer because my TI-84 SmartView thing is not working yet. I'll get that going. All right, so we have one more thing that I want to talk about, and then I will be done for today. This concept of a stratified random sample and how it's different than a simple random sample. Now, again, we are talking about how to sample well, so this is a good sampling method. Now, for a simple random sample in the high school student example, is a little bit tough to obtain. We have 650 or so students, and we're trying to find 40. So we have to number every single one and then go out and find all of those people. So that's one kind of issue with an SRS. SRS isn't bad, but it's just kind of a tougher method to do. Another reason why an SRS isn't the best method in this example is because it is possible that the 40 students that I get are the 40 tallest students in the school. So that's not going to give me a very good estimate. It's also possible that I get the 40 smallest students in the school, or 40 males or 40 females. So that would kind of give me an estimate that's not necessarily correct. Now, is that very likely to happen? No, but it could happen. Okay? So a stratified random sample can help you kind of control some of those variables that might affect your estimate. So a stratified random sample is a sampling method where we classify the population into groups. We call those groups strata in this case. Then we choose a separate SRS, a separate random sample within each group or strata, and then combine them to form the sample. So you can group them however you want to. In the GAC student example, you can group them by male and female. You can group them by grade. You can group them by age. You can group them by whatever you want to. But it would be best to group them by something that classifies height. So in this case, it might be best to classify by grade. So let's do it by grade, and I'll give you an example. So for grade, I would have 9th grade, 10th grade, 11th grade, 12th grade. And within each group, within each grade, I would take a simple random sample of 10 students. So for the 9th graders, I would number the students 1, 2, however many 9th graders are, like 143 or something like that. And I would get a simple random sample of 10 students from the 9th grade. I would do the same process with 10th, 11th, 12th. You could also go on and group by gender and age. So I could get 5 male 9th graders and 5 female 9th graders, 5 male 10th graders, 5 female 10th graders, and so on. What you want to do is you want to have a sample that is the most representative of your population. And stratifying helps us do that. That's the goal of stratified random sample. Sometimes it's a better method than just a simple random sample. So what's the benefit of it? You're getting what we call a more precise estimate. It's not going to produce a more accurate estimate. We'll talk a little bit more about the difference between accuracy and precision. But the benefit's a more precise estimate. Our estimates will be less spread out. Okay, and we're choosing the variable that's the best predictor of what we're trying to measure, the one that has the strongest association. In this case, the strongest association to height is probably grade, and gender might have an equal association there. If you do have any questions about this lesson, please let me know. Come in, see me on Monday, or shoot me an email. And we'll stop here and pick up on Monday about 4.1, talk a little bit more about sampling. All right.